Now we'll be seeing the how to find the common big O classes from a particular code. So calculating and finding out different big O classes from a certain code. So here we have a code example, which is a binary search algorithm written in C++. This is taking around all of log n time complexity as its worst case analysis, and we will see an example how this exactly is O log of n. So here I'm going to just ask how to find the time complexity in this code. So this is a step-by-step time complexity analysis. It's the classic binary search. Check the middle element, and if cuts the search space in half, you search the right half, then you search the left half. How many times can you divide the array in half? Starting with n elements, each loop halves the remaining elements. You stop when the size reduces to 0 or 1. This happens approximately log of n times. So each iteration does constant time work, comparisons, index calculations. Now, how exactly does this take off n? It's an interesting concept. Let us ask it to explain in detail as to how this came to the conclusion log n.
Taking photo.
Explain per line for per each iteration. So when we see it like that, as for binary search, as we know in a binary search, it starts from like in an array, it will take by half and it will go by half of that. I wouldn't be explaining binary search how it will be working, but it will be good to have a look over it and other sources. So we have the binary search over here, which goes by each iteration, cuts the current size k to about k by 2 until the size becomes 1 or 0. So if n is 16, first we check between 0 to 7 and 7 to 16 and eliminate half the array. Next iteration will be 8, and the mid is 4, so 0 to 4 and 4 to 8. So you choose a bit. Then size is 4. Then we will see from 0 to 2, 2 to 4. And then size is 2. Check between 0 to 1. We choose either of the sides. 1. So total iterations that we had is 5. And that is first time we it took n by 2 amount of time. It went from n to n by 2. Next time we had to search just n by 4 of the code. Next time we just had to find the iteration up to n by 8 until we just have to search over just one element. So each time this, if I'm right, it goes by induction solution. I really don't recall the mathematical way, but it's induction way of solving, and you find that each time n reduces by 2k value. So by doing the maths on it, we'll find that the k is log n. So if you perform log n iterations before you reduce size 1, so at least you would, each step does O of 1 work, and total time it does O of log n work. That's how O log of n comes. So similarly, we have calculations for all other forms of big O classes, and this way we can find the case analysis. Now big theta, or the tight bound, is the best case. I'm sorry, tight bound, upper bound. Let me just confirm if tight bound, upper bound, worst case, best case is omega. Okay, I'm sorry, this is tight bound or something different, and I think we should be looking over it as to what it is, because I have no clue about it. So here theta is very wrong. It's the tight bound. Stands for tight bound, and this stands for upper bound. What the bounds are, we'll have to check out later. So that's just for how the calculations are done regarding this video.